Hello, today we are diving into an interesting topic. What happens if we fall into a black hole? First, let's take a look at the nature of black holes. Black holes are among the densest objects in space, and their gravitational forces are so strong that even light cannot escape from them. This density typically results from the collapse of a large star at the end of its life. When a star reaches the end of its life cycle, its core collapses to become a black hole. There is a boundary around black holes known as the event horizon. This is the point of no return once you enter the black hole's gravitational field. As you approach the event horizon, it is essential to pay attention to how the gravitational force acts. When orbiting near a black hole, the gravitational force varies at every point. This phenomenon is referred to as tidal force. Tidal force refers to a situation where the gravitational force exerted by a celestial body, especially a black hole, varies on other objects nearby. This force arises because one part of the object experiences a stronger gravitational pull compared to another part. For example, an object approaching a black hole is subjected to a stronger gravitational force from the part of the object that is closer to the center of the black hole. A difference in gravitational pull occurs between the upper and lower parts of your body, creating a situation known as spaghettification. Spaghettification is a physical transformation that occurs when an object, particularly a human, is subjected to the extreme gravitational forces of a black hole. This concept arises from the variation in the gravitational pull exerted by the tidal forces around black holes on different points of the object, depending on its own structure. As you approach a black hole, the lower part of your body experiences a stronger gravitational force, while the upper part is subjected to a weaker gravitational force. This results in your body stretching and taking on a thin, elongated form, much like a strand of spaghetti. Spaghettification can lead to the breaking of bonds between the atoms of the object and ultimately its disintegration. Thus, this frightening process that occurs when falling into a black hole can cause a complete transformation of your physical structure, leading to your annihilation. Spaghettification exemplifies the impressive and terrifying nature of black holes, and this phenomenon is a crucial concept for understanding the universe's most extreme conditions. As you make your way toward a black hole, your perception of time also changes. According to the theory of general relativity, time slows down depending on the strength of the gravitational field. This is quite intriguing for observers at a distance. While you are falling into the black hole, time continues to pass much more quickly for those outside. For example, while you are falling into the black hole, perhaps years could be passing for people outside. This presents an interesting perspective for observers. For someone falling into a black hole, only a few seconds may have passed, while for outside observers, it might be decades. Once you fall into a black hole and pass the event horizon, it becomes quite challenging to know exactly what will happen. Scientists still do not fully understand the conditions inside black holes. However, theoretically, there is a point at the center of a black hole known as a singularity, where the gravitational force is infinite, and the known laws of physics do not apply. It is believed that everything related to matter and information ceases to exist here. Falling into a black hole raises interesting questions not only about physics but also about the nature of the universe. For instance, the black hole information loss problem is a significant topic of debate in the world of modern physics. Is information truly lost inside black holes? This is a puzzle that scientists are still trying to solve. Infinite gravity is a phenomenon that arises at the singularity point at the center of black holes. The singularity is a point where the laws of physics cease to be valid, and density, and consequently gravitational force, approaches infinity. At this point, all the mass of the black hole is concentrated in a region with zero volume. As an object approaches the singularity, the gravitational force increases to such an extent that all physical effects on the object exceed the normal laws of physics that we know. In this situation, the structure of the object is disrupted, and its existence becomes questionable. Thus, under infinite gravity, the nature of matter and time changes. This creates an area that scientists have yet to fully understand and explain. According to the theory of general relativity, this situation leads to questioning the structure of the universe and its fundamental laws, as classical physics fails to hold in such extreme conditions. Another interesting aspect of infinite gravity is the discussions related to the black hole information loss problem. When an object falls into a black hole, it appears that the information and matter within it are lost. However, according to the laws of physics, information cannot be lost in the universe. This is one of the fundamental principles of quantum mechanics. Therefore, when an object falls into a black hole, is the information contained within it buried in the dark depths of the singularity, or does it transition to another dimension? These questions are a major topic of debate among physicists. Some theories suggest that information is not lost in black holes, but due to uncertainty principles, it appears as though this information has been lost. The relationship between infinite gravity and the information loss problem is a crucial junction for understanding the nature of the universe, and research in this area continues to develop new perspectives in both general relativity and quantum mechanics.